I will give a talk on threats and betrayal on the internet. And before I do that, I would like to say just a few words about myself and this lecture. So my name is Andreas Jacobsson. I'm an assistant professor here in computer science here at Malmö University. So as Katarina said, this is a docent lecture. In this lecture, I will try to provide an overview of my research areas in general, and also introduce you to the study environment of my research, and in the end give a few examples of the research results that I've contributed over the years. Hopefully the lecture will be of a rather broad interest, and the lecture will last approximately no more than at least 45 minutes or so. So then a few words about my research areas. I've tried to nail them down here in a table in order to illustrate where my main research areas are, but also give you an insight on some of the examples of approaches that I've used in the study of the research areas. And as well, in the final row here, provide you with some examples of the application areas that have characterized my research. So as you can see here on the main research areas, I've been involved in mainly in 4 areas, and the first 3 are security, privacy, and trust. And I think a common factor for the study of these 3 concepts is that when you study things related to these areas, you generally tend to study sort of the dark side of things. You analyze what can go wrong, what people could want to, for instance, hack my information resources or send malicious software or the like. So this is really about the protection of assets and trying to keep in control of your assets and keeping them close to you. Whereas interoperability, the 4th concept here, it's rather the opposite. It's much about trying to share information resources with other peoples and systems in order to help them get use of what you are doing or what you have been doing. So this duality here has been really interesting for me, I think, because it tends to get a bit too dark at times when you only think about what can go wrong and who can use it in selfish or malicious ways. So as you can see here, when it comes to security, I, for instance, studied security by an approach of, for instance, Agile software development. I've used evolutionary biology. When it comes to privacy, some examples might be software experiments or machine learning. And when it comes to interoperability, I've mainly studied that area in the context of formal model, normative systems, etc. And some of the application areas that have been the object of my study are, for instance, Internet of Things, smart homes, ERP system, file sharing systems, or, for instance, virtual enterprises in the context of interoperability. As much as I would like to talk to you about every single aspect of the things that are included in this table, there isn't that much time to do it. So today I tried to set the focus, and the focus will be around the main research areas of security and privacy, and I will mainly take you through the application areas of IoT or Internet of Things, smart home, and mobile money transfer system. And I will also show you some examples of the approaches that we've used in studying these concepts in those areas. So that was a few words about my research areas in general and the research that I will present here today in particular. But before I get to that, I would like to introduce you to the domain of Internet of Things, but not only Internet of Things as such, but also Internet of Things and security and privacy. So this is the part where we get to the sort of dark side of Internet of Things. So bear that in mind, because I will probably say a lot of the stuff that can go wrong and how people can take advantage of that. Obviously, there are many, many good things about IoT as well, very many positive things where you share and you care for each other and you develop smart and fun ideas. That's also true. But the purpose of this, or the focus of this lecture here, will be on security and privacy. That is the dark side of things. So before we get into that, I would like just to say, what is the IoT? Well, basically, it's when everything is connected, or rather, everything that benefits from connected is connected or will be connected. So in this sense, connectivity is ubiquitous. It's connecting everything everywhere all the time. And this is done mainly to 2 reasons, I think. The first and foremost, we have knowledge about how we could do it. But that is not sufficient. The second one is that technology has become affordable. It has simply been doable in connecting everything and everywhere to the internet. But I mean, that's kind of broadly speaking. If we were to think about this in more detail, I would say that the IoT, more precisely, it's a network of interconnected objects that process data. And by that, it's also highly specialized and often embedded in other stuff and in other things, like jackets or shoes or coffee brewing machines, etc. So by that, it's also a user-oriented paradigm. And since it's so playful, it's also an area where there are multiple stakeholders involved, representing multiple different perspectives, adding a very complex digital ecosystems of actors. It's usually integrated in the legacy systems or in an independent infrastructure. When we talk about IoT, we actually talk about the cyber-physical system. That is a system where the digital side of things enters the physical side of things. As it is a part of the internet family, you can also say that it inherits all the characteristics from this sort of old school internet. And by old school internet, I primarily mean when you sit by your computer and interact with the internet. That's like the only point of interaction with the internet you have is through your computer. So obviously, in this domain, there are just as many application areas as there are sort of old school physical application areas in the world. So I've mentioned a few here. For instance, you can say homes. When a home gets connected to the internet, it becomes a smart home. The same goes for cars and sport. Instead of doing monitoring and governing your sport activities in a lab environment where you have people in white lab coats overviewing your activities, you can simply go out and run or play on the field and have equipment attached to you that measures your performance and help you understand how to improve your health or your performance. The same goes with healthcare. And I was adding this morning kids' toy to this list as well, because I suddenly remember that my oldest daughter, Ebba, she plays with a doll, that she has a physical doll. She plays with it through an app in her mobile phone. And not only that, she plays with some of her friends who has the same sort of doll with the same app, so they can really play together even though they're not sitting in the same room with the same sort of toys. And obviously, I mentioned clothes, and the final example here, cities. I mean, if you can include homes and cars and clothes and people to the internet, then of course, another thing about IoT is the scalability, meaning that you can suddenly connect houses, to roads, to cars, and suddenly you have smart cities or even smart countries. So, if it's still not clear, I would like to just introduce some, or maybe not introduce, but to some of you, remind you of some interesting updates on the Internet of Everything and Everywhere. I mean, you see a lot of predictions about how big the Internet of Things will be. But we can say that at the end of 2012, around 8.7 billion connected things were found in the world. In 2020, some institutes predict that there will be 50 billion connected devices and 8 billion people on this planet. However, Ericsson, for instance, assumes that by 2030 there will be 500 billion devices since the development of 5G. So no matter what figures you look at, we can conclude that there are quite many connected devices in the world today, and there will be even more. So many that it will be difficult to comprehend. However, interestingly, Accenture found in a recent report that the majority of people have not yet heard of the term of Internet of Things. They say that 80% of the people in general have no acquaintance with this term. Kind of interesting, I think, especially since the term was added to the Oxford Dictionary as late as in August 2013. And I think they also provided a very crisp definition. They say that the Internet of Things is the connection via the Internet of computing devices embedded in everyday objects, enabling them to send and receive data. Very crisp, I think. So if you want to find connected things, you tend to not be able to go to Google, because that's that search engine might be fantastic, but it doesn't hold the answers to these sorts of questions. Instead, you might turn to the world's first search engine that finds connected things around the world, and that's Shodan. You can find it on shodan.io. And even though it's a bit complex to use, when you get used to it, you can not only find stuff, but you can also play around with them, if you know what I mean. Something about the vehicles then. By 2020, 250 million vehicles will be connected to the internet, giving us completely new possibilities for in-vehicle service, automated driving, and car safety. Actually, I also read yesterday that Google's self-driving car adds approximately 10,000 new miles of driving every week. So this is a part of the world that is also going to be more and more commonplace. So around 10 times the population of Sweden will live in smart homes by the end of next year. And actually having a connected kitchen could save the food and beverage industry as much as 15% by 2020. So by sharing information about what we eat and to what extent we eat it and drink it, of course, we can learn a lot from how much food and beverage that is really need to be produced and distributed and where it needs to be put. A final thing here is that in 2015, over 1.4 billion smartphones were shipped. By 2020, we will have a staggering 6.1 billion smartphone users. And this is interesting. For instance, because of that, today, nearly 60% of the consumers that shop online use smartphones to shop. And the interesting thing is here that shopping through the smartphone has proven to fortify customer loyalty. And this is really something that online companies have been struggling for years. That is finding ways of strengthening customer loyalty so that they will return to their online store as a customer. So while these are not only interesting but also quite positive facts, I would like to remind you that in one of the recent studies that I read, over 80% of the connected devices that they investigated leaked private information such as name, email, home address, bank account details, and health data. And I can only confirm this. 1.5 years ago, we had a student project where students tried to eavesdrop on information that was sent through Internet of Things and sports equipment, such as Fitbit, etc. And they could easily get hold of such personal information. But not only that, but also movement tracking, etc. So this is something I think that's important to bear in mind. So having said all this, if you compare the new Internet of Things paradigm with the old traditional Internet where you interact through mainly a computer, is there a difference? And what is the difference? Well, I can think of a number of things, or at least 5. The first one is the fact that there is a device. IoT is truly a hardware-intense computer paradigm. And in that sense, this is not new, however, but ease of use is almost always at odds with security, especially when it's such user-oriented as it is in the IoT. But I would also like to highlight the longevity of the device. Updates are definitely harder than when you update software in a computer. And sometimes they're impossible, and you don't even have them as long as you have computers often. Also, the size of the device, this is obvious to some extent perhaps. With small computing devices integrated in, for instance, an environment such as the home, there are limited capabilities, and this is especially something that has an effect on the level of crypto that can be enforced in such system. And crypto is really important in terms of security. It's the closest thing to a silver bullet you get in the security area. So encryption solves many of the problems that we otherwise would have difficulties in managing in terms of security. The data. I mean, when there are tons of connected devices that constantly overlooks or reads interaction in an environment, there's a lot of data that is going to be gathered. And since the data is often concerns people, the data is often highly personal and thus very sensitive. So another difference, the final difference here might be the mindset. I mean, appliance manufacturers, they don't always think like the established software developers do in terms of, for instance, security and quality criteria in the development phase. Quite the contrary, actually. And the embedded systems that make out the Internet of Things, they are often developed by grabbing existing chips and designs, etc. And who knows what sort of quality or security criteria that has been involved in the development process there. So this might seem cool. Is there something that's wrong? And if so, what? Well, these 4 things spring to mind here. The first one is pervasiveness. I mean, in the IoT, as we've seen with the predictions from Ericsson or from Cisco or Forbes even, you won't have one Internet of Things connected device. You'll have 10 or 20 or 200. And that's really a lot of new attack surfaces to your life and your business or your home or your car or whatever. Uniqueness also. I mean, a difficulty, something that we learned to manage in the sort of old school Internet is to make generalized security protection measures. That if it works on one Mac, it usually works on every Mac. The same goes in principles for the IoT. But since the IoT devices are a wild west of mixed technologies, uniqueness makes it hard to enforce security. And how do you patch firmware in this multitude of devices? And which random vendor made the hardware inside this or that device you're using? And again, what type of security criteria was used? Also, there's an ecosystem perspective here. The vendor you might be using may be leveraging 6 or 16 or 66 other vendors. So where's your data going once it has entered that IoT device? And who has access to your network via the proxy connections that you have enabled? There is, again with the attitude, a rapid development here. And in such a scenario where there's fierce competition, where there's a dynamic ecosystem with lots of scalability, etc., who has really time or the energy to think about security? So I'm sensing here that there's a shift underway. I mean, the IoT growth that we're expecting, that is predicted by Ericsson, for instance, will not just be from large vendors. Like I mentioned 3 here, Belkin, Google, or Ericsson. There are a lot of organizations available out there. I named 3 here, Postscape's IoTlist.co and Wolfram Alpha, that lists some 100 or even 1,000 IoT-related companies, most which you've never likely to have heard of, at least I hadn't. And I mean, many of the new IoT devices that we are using will be produced by crowdfunding websites where users go together to fund the development of new cool stuff that we all want to use. And the list could go on. And as a final note here, I mean, entrepreneurs, the ones that are driving this development, they are likely to have no experience with security whatsoever, nor the budget to afford help. This is the way. So that was a bit thinking about IoT from the perspective of security and privacy. But if we nail it down, is there any particular security concern that we should bring up? Well, when it comes to security, security is all about the protection of something from harm caused by someone or something. So it's a protection of harm, really. So in the IoT, the connected objects, they're small and they're everywhere. And that means that they're prone to environmental influences. They can also be found, especially in the home, in unprotected places, or in shops and stores, and thereby go unnoticed, thereby encounter unnoticed manipulation. And since the possibilities for calculation and memory power are so weak, it means limited means for crypto. And again, this is something that the community is struggling with. Also, the objects are working autonomously. At least to some extent, they're acting without user awareness or even control. And so, whereas in the old school internet, cyber attacks were mainly digital or vertical, cyber attacks in an IoT connected scenario where more and more of the everyday items that we interact with are connected to the internet, cyber attacks get increasingly physical. You can just take the example of the computer system in smart cars that was vulnerable to onboard attacks, which was very popular in the media reporting on IoT a few years back. And I mean, if you think about it, an Internet of Things connected car is really like traveling in a big Internet connected computer. And the same goes for airplanes and stuff like that. So to be brief here, to be short, this is an attacker's dream. What about privacy then? Privacy is a very difficult concept to define. even more difficult to translate. Most languages don't have their a truly properly reflecting definition of privacy. Swedish is one such language. But we in English, we usually say that privacy is the right to be let alone. And with the IoT, there is, and where there are many multiple connected sensors and actuators and things around us that constantly collect data about us and distribute that data, there is an explosion of data. There are massive amounts of data, and more data than available than the world has ever seen before. So in this sense, an object can reveal information. A single object can reveal lots of information about a specific individual. And since it's information about an individual, many times it's personal and thus it's sensitive. And we have seen more means to spy on people, for instance, in their own homes, than the world has ever seen before. IoT also introduces new ways of collecting and processing such information from objects. There can be collection of data from different sources, for instance, in a home. If you have access to that, you can correlate and associate information and thus create rather extensive information portfolios on the people living, for instance, in the home. And that means that the abuse potential is higher than ever. There's also a lot of the decisions about the personal information that takes place without the user's awareness or control. So where does that leave privacy as the right to be let alone? So privacy is something that it has an ethical side, and in that side we have all agreed, the human population of the Earth, sort of, that there are some principles that the right to be let alone must be reflected in accordance with. And one thing, and an easy way of getting into these privacy principles is asking simply sort of these simple questions. How do you obtain informed consent? This is really the foundation for sharing personal information, or a company to be able to use and take advantage of personal information that they collect about customers, for instance. They need the customer's informed consent in order to do that. And on the user side, you need to be able to control the data that is being collected. And you also need to be able to erase the data, for instance. And how do you do that in an Internet of Things connected scenario where there are multiple systems with multiple sensors that collect and distribute information about your movements, for instance, in a house or in a home? And if information is collected, who then is responsible? How can your rights be exercised? I mean, this is difficult as it is in the sort of old school Internet. Moving into a scenario of Internet of Things, the complexity increases. There's also the point that data need to be safeguarded. You need to be able to trust that the company that you share your data with can actually take responsibility and safeguard your data so it won't end up in the hands of, for instance, malicious actors or the like. And if attacks occur, how do you detect them? How do you even detect espionage activities that might take place, for instance, in the home? How do you overview or evaluate damages? These are challenges that I think the research community need to devote themselves in the coming year. So having said that, I would like to just say that in my view, this is a brave new world. And I would like to say the following. Imagine a world where all news you encountered are based on your salary, where you live, and who your friends are. Imagine a world where you never discover new ideas and where you can't keep secrets. Imagine a world where your closest neighbor is your friend or your worst enemy. And by that, welcome to the Internet of Things. So that was the introduction to the area of Internet of Things and security and privacy in general. I would now shift the focus and go into a bit of the research, examples of the research results that I've contributed over the years. And I will begin by some studies we have done on privacy and security in smart homes. But before that, we need to ask ourselves, what is a smart home? Well, obviously, it's a home. It's a place where you live, where you keep your pets and plants and all the stuff that you treasure, right? That's the place where what happens in the home should stay in the home. But the smart home is a home that's connected to the internet and thus uses IoT technology. A smart home allows for remote control, often through a smartphone or some other handheld computing device. In a smart home, you're able to acquire and apply knowledge about the home and its inhabitants in order to improve their experience in the home environment. So whereas this can seem rather new and novel, it's actually not. The first smart home came already back in 1969. It was offered by the department store Neiman Marcus and was called the Honeywell kitchen computer. And you can see a picture of it here. It weighed 45 kilos. And you could do two things with it. Basically, you could add recipes and you can store recipes. That was mainly it. Well, this is not kind of unique for this area. It's often the thing I find it that when you think that something is new and you think about it some more, you found out that it's not really, or at least entirely new. And the same goes with the smart home. On this slide, there are some examples of the smart home market, which attract a lot of attention from both commercial actors, but also from standardization organizations and governmental institutions, as well as probably the most important group, the end users. The global market was valued to $9.8 billion in 2015 and is expected to grow to $43 billion in 2020. So just like the sort of general IoT example, this is a complex, dynamic, scalable ecosystem characterized by fierce competition and which lead to the observation that not much time and effort is generally spent on security. You see some of the logos of the key players in this area here on this slide. I'm guessing that you recognize most of them. However, I hope that there are some that you don't. So there's at least something new in this slide. But this is a really big area, and the area is expected to be even bigger in the coming years. So apart from the obvious then, why should one study security and privacy in this context? To me, this is all about information. This is all about the information that is generated in the smart home and distributed to third parties outside of the smart home. Because smart homes can collect massive amounts of data, some of which they can be really sensitive. For instance, in terms of behavioral pattern. I mean, in the home, that's where you do the things you do when nobody's watching or looking. But if the machines are looking and watching, maybe the home is not really the home anymore. So this is an important aspect. But also information about your location, the resident's location. Where are they? Or rather, where are they not? I can think of at least a number of agents that would be more interested to know where you're not as opposed to where you are in relation to a smart home. I mentioned health and medical status, but also home monitoring and control. I think a few years back the internet was almost flooded with examples of people who had integrated smart security cameras in their homes, but unfortunately had the bad luck, so to speak, to have their video clips ended up for public display on the public World Wide Web. Not desirable, I'm guessing. And also the information and distribution process in smart home is typically done out of the control for the users. So this too is an example of where much of the things are done without user awareness or control. And just as all other things that can be found on the internet, smart home systems can be manipulated, hijacked, or attacked, impacting not only the personal, but also the private, and not only the digital, but also the offline lives of users. And in essence, to me, this is why this area is so really, really interesting to study. Here we have a scenario where not only the digital threats remain digital, they come to life and impact your physical surrounding. So, whereas it might seem like I'm really smart who has thought about this all myself, it's in fact not entirely me. Enforcing security has been previously identified in a number of papers as one of the main barriers for realizing the vision of smart homes. That means that a lot of effort should be put into study of security and privacy in this context. So, as I said, there have been some research initiatives going on in this area. We are in the research project that I'm currently involved in. We are doing state-of-the-art surveys, and we have done a number of those in the past. This is one example of a state-of-the-art study on security and privacy in smart home that was reported in an article published early this year, but the study was done in the beginning of 2015. So these contributions here are basically all the contributions that could be found, relevant and high quality sort of contributions that could be found from the academic perspective on security and privacy. You can see here that most of the contributions, they have focused on security issues, security solutions, and to some extent on privacy issues and privacy solutions. Only 3 of them, a small amount, in my opinion, has focused on risk analysis. While this may not be surprising, it's still a bit strange, because when you want to analyze and define a comprehensive security strategy for some digital assets that you want to protect, this must be something that follows a risk analysis. Because in the risk analysis, you define what you want to protect and to what level of importance it's important for you to protect it. This information is crucial if you're going to make a resource-efficient yet sustainable information security strategy. So on the last row here is how we position risk analysis methodology design that we sort of developed and applied on a smart home automation system. And here you can see that we focused on risk analysis, but also on stating the problems in connection to security and privacy, but we only discussed very briefly some recommendations for how to handle those problems. And this was an empirical evaluation and a scenario-based study. So, as I said, this was a risk analysis study that we applied on a smart home automation system intended for a more efficient use of energy. And this system was actually developed in a rather big research project here at Malmö University. And the system enabled end users to both monitor their energy consumption and as well remotely control the electronic devices that were connected to the system in the buildings and homes that were in question. So based on the main observations from the state-of-the-art study, we applied a risk analysis approach that was a modified version of the well-known information security risk analysis. It was modified in the sense that we adjusted or added, we made a classification of the system that we reviewed along the lines of information system science perspectives. So the whole point of the ISRA is to evaluate the system's ability to meet the basic goals of security, or rather the CIA of security in this case, confidentiality, integrity, and availability. So in the risk analysis approach, we made a review of the technical documentation of the system and as well as the system architecture. We had group interviews with the system developers and the domain experts in 2 sessions. We identified 32 risks that were then analyzed and evaluated. Of those, 19 were classified as moderate and 4 as high. Remaining were considered low. So on this slide, I've prepared a brief compilation of the main results. You can see here that the most severe risks were directed towards human use, where poor security, hygiene as we call it, when you are sloppy with password selection and you have a lot of gullible users around you, we found that they constitute the main risk sources, with implications primarily to confidentiality and as well as user privacy. Software-related risks were also severe, especially those found in the software that was included in the in-house gateways, the mobile apps and the APIs used. They brought on implications to system confidentiality, integrity, and availability. Information-related risks were mainly connected to security procedures such as authentication and access control processes that were placed on the cloud server of the system. And that impaired primarily implications to availability of user and home data, rendering in the long run that the smart home could be exposed to a denial of service attack. So if I were to give you some main observations from this case study, well, this is an area with a lot of different stakeholders that are involved in the smart home market. When such a case is present, it's always very difficult to analyze the risk exposure. Things are connected to each other in ways that are difficult to, and sometimes meaningful to analyze. Most sensitive part we found was information registry about users' energy consumptions. That while that might seem harmless in a way, conclusions, if you add and associate the information with other types of information, you can draw conclusions about the inhabitants' daily life. Where they are, where they're not, how they live, when they get back, when they leave, etc. And at this point of view, user privacy, but also home security is at risk. So we also could confirm that the general system constraint in these types of systems is the limited computing capacity for instance, encryption. When thinking about security design for such system, we could conclude that it was primarily important to be conscious about or particulate about authentication and access control procedures. As a sort of a meta-reflection from this study, we could also see that we evaluated security based on a risk analysis from the outside when the system was almost already in place. So ideally, security should not be handled that way. It should be integrated in the very design or the development phase of the system. And this is not a new insight. This is, has been a research challenge to researchers within my area for many, many years, as long as I've been involved in the area, at least. We've talked about security in design and the difficulties in actually adding security. There have been many papers that have pointed in this direction, but very few had been able to back their statements up with empirical data. So, having said that, we thought about this challenge for a while and then decided that we would try to include security aspects in this case, Agile software development method. And this model that we developed, we call it the Security Enhanced Agile Software Development Method, or SEAP, was applied for testing in the development of a cyber-physical system, that means an IoT system, for mobile money transfer that was developed at Ericsson. And usually when Ericsson deploy, when they do software development, and they do that a lot, they usually use Agile software development methods. And when they do that, they typically handle security and risk analysis by an external security manager and only once every new system or major system release. So this is something that is typically handled from the outside and only once every new system release. So in SEAP, we had the idea that we wanted to break down the security management role that normally is put as an external perspective at each new major system release. We had the idea to add that from the inside and break it down to 4 different competencies. So we did that and added those competencies to each development team in this study. So we kept the security management or security manager. This is the guy or girls that sort of holds everything, binds everything together, that often leads the risk analysis work and makes sure that there's documentation and have sort of a holistic view on the system that is being developed. Then we added the perspective from a security architect who sort of reviewed the system's security from an architectural point of view. We had security expertise, which was allowed to be really in-depth, knowledgeable and nerdy, so to speak, about the security questions in the development. And since this was a system that was intended for mobile money transfer, robustness was particularly important criteria here. And for that matter, we added a penetration tester who had the opportunity to test the system from the outside via the so-called pen testing methodologies. So the way to do this was to add to conduct risk analysis within the development teams. Instead of once every new major system release, this was done several times during development. And it's the documentation from this work that we have reviewed and analyzed. And in short, a compilation of the results look like this, even though there are a lot more graphs in the paper, but this is a compilation. So the study involved 88 staff members at Ericsson, and they were distributed among 8 development teams and 4 versions of the system. The study took place in the early hours of 2015. I think version 1 here is particularly important to mention. In this version, Ericsson used the old traditional Agile software development method. Not at all SEAP. SEAP we integrated in versions 2, 3, and 4. So version 1 here represents the typical normal case at Ericsson. This is generally how they do business. And we could see with the addition of our 4 security competencies and an ongoing risk analysis process in the development teams that the number of unhandled, the number of corrected risks went up, the number of postponed risks went down, and the number of unhandled risks also went down. So these were really good and interesting results. We could finally back up some of the work that many other researchers have set out to investigate previously. So some main observations then. SEEP found significantly more severe risks because of the more detailed and integrated risk analysis fashion. I mean, if we have more people thinking about security on a daily basis, I think it's only normal that more severe risks are left unhandled, for instance. So we also could see that 5 times more corrected risks. We went up from 13 to 67%. We left in the SEEP, we left fewer risks postponed to future software version. It was a decrease from 38 to 11%. The number of unhandled risks went down from 50% to 21%. So obviously our method was, on an immediate glance, it seemed like it was much more expensive. We used 5% of the total project cost instead of the 1% for the traditional Agile software development methods. So whereas SEEPs might seem more expensive, it's not entirely clear that that is the case, because the integration of security and Agile software development, that is SEEP, contributed to a higher level of time efficiency in the software development, which benefits product robustness and quality and a lot of other good stuff that consumers tend to appreciate while they do have got hold of the project, or the product, so to speak. So the results here were basically very good and cheery for us. And having said that, I would like just to say a few words about the future. Before, in preparation of this lecture, I asked someone what to think of, and she said, well, it should be something from the past, something from the present, and something from the future. So this is the part where I try to say something about the future. So, in the work that characterizes the road ahead, there are 5 endeavors that we have committed ourselves to. And the first 2 ones are in progress. The first one is trying to make a generic description of the smart home. This really is intended to be a way of making the practical commercial area of smart homes into a more scientific area, where we have set the goals to define a formal model that can be used as a reference model for other researchers as well as commercial actors in the area. The hope is that with a crisp description of the smart home entities and actors that are involved, we will make a more deeper understanding of the area in general, which I think is something that would lift the area in general. So the second bullet here, smart home data categorization. I mean, when you read, you only have to read the abstract of a lot of the research papers here, and they will all point to that information is highly personal, it's very important to protect it, yet nobody protects the information, so this is very problematic. So our view here is that, okay, let's say that the information is personal. Now we want to investigate what of the information is actually very sensitive and what is not particularly sensitive. Could we even classify the information along with sensitivity and with respect of privacy? If we can do that, we can probably, that requires some better understanding of the data in flux in smart home. And such an understanding could benefit not only the scientific area, but also the companies that are delivering products in this area in general, and in particular the users, in helping them understand what part of the data traffic in a smart home is really sensitive, what should you be careful about, what is not that sensitive. So the top 2 bullets here are work in progress that we are hoping to be able to report on soon. And the other three are stuff that lies ahead. The first one here is to explore to what extent the smart home users are interested in managing their personal information and how they practically could do it. Remember that I said that most of the stuff that goes on in, for instance, smart home is taking place without user awareness and control. So this would be an effort in trying to get the users to understand and also show what type of level of personal information that they would like to manage themselves. And if so, how could they practically do it? So this is not only important, this is also fun, and it's fun because this is work we are planning to do with people from interaction design, and I'm looking forward to that, for, if not for any other reason than for that. I think it will be fun. The fourth one here is trying to take the lessons learned from the development of SEEP, which I just showed you, and try to exchange security for privacy, and thus try to integrate privacy aspects in the design of smart home products and software, as opposed to adding privacy in the very end of the development process. I mean, if this is generally hard to do when it comes to security, or if this is generally rarely done in terms of security, it's even more lagging behind in terms of security. And I think for the general user, privacy is often more important to defend than security in a smart home system. So the final bullet is also a particularly fun bullet to investigate. We will try to make an analysis of the motives, the opportunities, and the methods of smart home threat agents. That means to analyze what type of threat is actually directed to the smart home environment, and what are the things that motivate threat agents in this context. This is equally, of course, very interesting to understand if to be truly able to sort of lift the general level of security and privacy in smart home, and thus helping to realize the vision of smart homes that we all want to do. So if you have interest in this work, you're welcome to, of course, talk to me whenever you like. And if not want to talk but still be interested, you can follow our updates that will be shown on the IOTAP website and in the particularly the project area of our research project. Thank you all very much for bearing with me and for listening.